Hey guys, welcome back to my channel. I'm Advaith Pillai, and today we are beginning a new series, and this is going to be on logarithms. So let's begin. So first of all, before starting logarithms, let's look at indicial equations. The equations in which the unknown variable is in the index power or exponent is called an indicial equation. We have an example over here, and this is a raised to x is equals to b. Here, the unknown variable is x, and this x is in the power, which is also known as index or exponent. So such an equation is known as an indicial equation. Here, x is the unknown variable, which is the power, exponent, or index. A in this equation is known as the base, and b is simply the argument or the solution of the equation. Now, let's move on with logarithmic equations. So a raised to x is equals to b, which is an indicial equation, can also be written as log b to the base a is equals to x. So this is now a logarithmic equation, and this is equivalent to the indicial equation which says a raised to x is equals to b. So basically, if you look at this equation, we come to know that a raised to x gives you b. Here, a raised to x gives you b. So this is how a logarithmic equation is formed. The above equation is a logarithmic equation where a is the base again, x is the power which is now on the right hand side, and b is the argument which was passed in the indicial equation and now it is written with the log value. Okay. So there are also some criteria for forming a logarithmic equation, and these criteria are a is not equals to 1, a is greater than 0, and b is greater than 0. Here, a greater than 0 also means that the value of a can be between 0 and 1. Okay, let's move on and look at some properties of logarithms. So, laws of logarithms. First, we have the three main laws, and these are the product law, the quotient law, and the power law. Let's look at the product law. If the argument passed is in multiplication, for example, here log xy to the base a, multiplication turns into addition. This is similar to the indicial law, indicial product law, where a raised to x multiplied by a raised to y is equals to a raised to x plus y. So this is the laws of logarithms are basically converse of laws of indices. Therefore, log xy to the base a is equals to log x to the base a plus log y to the base a. So this was the product law. Now let's look at the quotient law. In the quotient law, instead of multiplication, there's division, and instead of addition, there's subtraction. So this is similar to the indicial law as well, where a raised to x divided by a raised to y gives you a raised to x minus y. So the laws of logarithms are can also be known as converses of laws of indices because the operations are very similar. Okay, let's move on to the power law now. The power law states that if the argument passed has a power, here log m raised to n to the base a will equal to n into log m to the base a. Here you can see that the power has been pulled down by the logarithm. Therefore, it becomes n log m to the base a. So this is how the power law works. Okay. Now let's look at the change of base theorem. For example, let's say we have log 7 to the base 4 and we do not want this. Let's say we need it to the base 10. So for writing this, we write it as, so if you look at this practically, we know that 7 is placed above 4. So therefore, we convert it into a ratio or a division or fraction form. And here log 7 will be on top and log 4 will be on the bottom. And here, the base can be any number you want. So for us, we wanted 10. So if we write log 7 to the base 10, the whole divided by log 4 to the base 10, this and this mean the same thing. So therefore, the change of base theorem states that log b to the base a is equals to log b to the base m, the whole divided by log a to the base m, where m can be any number you want. M can be any number you want. Okay, let's move on. Now let's look at the corollaries of change of base. So a corollary means that forming new theorems with respect to one single theorem. We have already seen the change of base theorem. So now look at the corollaries, that is using the change of base theorem to form three more theorems. Okay, let's look at the first one. The first one is the argument has a power and the base has a power. So in this case, it becomes the power of argument divided by the power of base, and then the expression comes later, log b to the base a without the power. So this goes like, if let's say log a raised to n, b raised to m. So first we have to take care of the powers, and here the powers are m and m. And again, with a practical view, we know that m is above n. So while writing it as a fraction, we write it m above n. And then we just copy the logarithmic equation without the powers. So this becomes log b to the base a. So this is the first corollary of change of base theorem. Okay. Now let's look at the second one. The second corollary says that 1 divided by log b to the base a gives you log a to the base b. So if a logarithmic value is divided is if 1 is divided by a logarithmic value, the position of the base and the argument switches. So here 1 divided by log b to the base a, this gives you log a to the base b. In this, a was the base and now a is the argument. B was the argument and now b is the base. So this was the second corollary of change of base theorem. Now let's look at the third and last corollary of the change of base theorem. So if the power is the whole logarithm itself and the base in the indicial in the indicial part and the base in the logarithm part are equal, then the answer has to be the argument which is passed with the logarithm. So for example, let's say 2 raised to log 5 to the base 2 will give us. So first of all, let's look at the base. So we know that this is an indicial equation if we just ignore the logarithmic part. So this is in the form of 2 raised to x. Okay. So the base here is 2. And the base in the logarithmic part is also 2. So since the bases are equal, the answer has to be the argument which is passed with the logarithmic part in the power. So the answer has to be 5. So this is the third corollary of the change of base theorem. So that is it for this video. In the next video, which will be the part 2 of the logarithms, we'll see more of the properties of logarithms, and we'll also look at the divisions of logarithms into two different ones. So thank you guys for watching and stay safe. Bye bye.